Well, hi everybody, welcome to my shop. We're about to start work on this radio. Comes with this speaker here. Also comes with a turntable. It's not in my shop at the moment because it's too much to put in here all at once. So it's a combination AM shortwave record player with a rather large Markin speaker, which I've covered with cardboard here to protect it. So I've already done some work on the radio off camera. I replaced the power cord, so it has a nice power cord on it now. And I've done some preliminary testing. And guess what? It's not working. Replaced the rectifier tube, and there was a shorted 6BA6 tube, which is interesting that there's more than one defective tube. And there was a huge draw on the power supply. Okay, and you can see I've replaced this capacitor and this capacitor. And that solved the large draw on the power supply, so we no longer have the rectifier tube at risk, but we're still not getting any decent output. In fact, it seems a little inconsistent, so I think there's some more capacitors to replace in here, which is what we should attend to today, or now. I'll probably be working on this all day long. I also replaced this capacitor. That's a 10,000. I couldn't find the schematic, so I'm guessing 10,000 is right. The did I say capacitor? Resistor. This resistor takes most of the power supply current. The far side of the original resistor was showing like 30 volts, and the near side, the power supply side, was showing 180 or something like that. So the resistance of this was about half a megohm, which is way too high for this resistor. So without a schematic, I assumed it's going to be around 10,000, so I put a 10K, what's that, a 2-watt resistor there? 3-watt resistor. But like I say, it didn't seem to help too much. So we have quite a few capacitors in here to change out. And generally I don't like doing wholesale capacitor changeouts. The two I took out looked terrible. This one doesn't look too good either. So yeah, maybe we could have some fun doing audio testing through these capacitors. But I think, you know, these don't look bad at all. Except maybe this one. Well, why don't we do this one, and then we'll test the radio. Why not? We'll see what it does. That sounds like a good idea. So I can also, since I have a new video camera I'm doing this with, this guy here. Let's see if I can't get a real good close-up on this particular capacitor here. I'm hoping my camera will autofocus to it. There we are. Need a little bit of a helping hand on that. It's this one here. There we go. Okay, so I noticed something interesting about this. I don't know if you can see it on camera, but this wire, this side of it, there is dust that has been electrostatically attracted to this wire. but on this side there is no dust. And I've noticed this on various components. Sometimes there's a high voltage side and you can see stuff like that. Just as a hint as to who's running at high voltage and who's not. So let's clip that guy out. .006, and let's give him a little test here. Not the best test, but let me just read the resistance on this capacitor here. And it should really, a new one would read open circuit. This one reads not bad. He's testing good actually. He's getting up around 50 megohms. That's pretty darn high. But the capacitance itself could be shot. When you look at the capacitor, you can see the seal is shot on it here. It's cracked open in this area. There could be some moisture in there, which will give us the lower resistance reading, but it's not much capacity to begin with, .006. Oh, that's kind of odd. Well, I can hear some warning sirens going off outside. I think I'm just going to check into that. Okay, I just stopped there for a brief moment to go and investigate why the nuclear emergency alarm was ringing in my neighborhood. You may or may not know, I live right next to one of the world's largest nuclear power plants here in Pickering, Ontario. Check it out on the internet if you want to take a look at it. It's got 8 reactors at it. It's a very large plant. And a few years ago the government put these sirens all over the place within a few kilometers of the plant to warn us all if there was some kind of emergency going on. It was quite controversial at the time when they set it up, because no one's quite sure, well, what kind of emergency would you ring those alarms for? And, you know, the plant's been there since 1964. There's never been any kind of emergency, serious one, that people had to run from it. So anyway, of course, now these sirens are all out there. Like any alarm system, it has to be tested periodically. And I'm guessing that's what was happening, because the alarm is off now. But when they ring those alarms, there's literally a 10 square kilometer area that just hears this howling, weird siren going on. It's kind of unnerving. But for now, I'm down in my basement, safe. So I actually live in one of the houses that's really almost as close as you can get to the nuclear plant. And I'm not scared. Lots of other things to be scared of in life. That's not one of them. So let's get back to what we're doing here, which is we're going to install this capacitor. And this is why I like to cut the capacitor leads and leave them, or the component leads and leave them hanging like this one, because you know, I ran out of the house here and came back in. I can't remember exactly where I'd removed it from just moments earlier, so you know, you never know when the nuclear disaster alarm is going to go off. So you got to be ready for those kinds of things. So, only kidding, of course. Hey, you know how nuclear reactors are used to raise uranium into plutonium for nuclear weapons, which is one of the main reasons why nuclear plants get built. And guess what? You can't do that with a Canadian reactor. You cannot make plutonium. So if the world had Canadian reactors, there'd be no concern about anybody making plutonium. Just a small little interesting fact. You know, the fact is, I think there's a heck of a lot going on in the world that ordinary people like me and perhaps you who are watching this know about, or we're never going to know about it. So, follow over there. Well, this is a new video camera I'm using, and I'm just learning the tricks of using it. It includes how to put it down. What is going on here? Very sorry about that. There we go. I think that's got it. I just got to show from here over to here. Okay. Very good. Yes, I'm very excited about this video camera. I think it's a good one. And I'm happy to produce better videos with it, except for some reason the computer I assembled here in my shop, which I'm using for this, keeps hanging up. And I'm not exactly sure why yet. I think it is related to the camera. Okay, that's done. Sometimes I have to stick my finger into the frame and look over at my computer screen to see if you can see what I'm seeing. You know, when I was using my tablet, usually I had the tablet aim pretty much like my eyeballs, so if I look down at the tablet screen, I was pretty much seeing what I was seeing anyway with my eyeballs. But now, for instance, the camera is looking at this view in a very different angle from my eyes. And when I look over at the camera, or at the screen rather, showing what's on the camera image, I can't necessarily relate it to what I'm seeing with my eyes. So I guess I'm not only learning radio repair here, I'm learning the ins and outs of technical photography done live. Okay, so we've replaced this one capacitor, and I really think, well, I don't think it made any difference to begin with. I think we should probably try this radio out. That might be more fun than changing a whole bunch of capacitors and seeing no benefit from it anyway. So let's let us give that a go. Oh, by the way, I'm really interested in feedback on video quality, and that can include my angles and shots and everything. Frankly, I don't sit and watch all my videos because I'm too busy making them. And I certainly appreciate any feedback I get. Helpful feedback anyways. Okay. Now, I especially like to know if this camera is working well. It seems to be. Now we got to hook up the speaker, or we're not going to have any idea what's going on. I could. Now these are pretty long. I think I'm going to solder them right to the wires that were cut. Whoever took the radio out of the cabinet, this is a big, pretty sure it's a big console type cabinet, just cut the speaker wires here. means I'll probably have to install some kind of a plug arrangement for this person so they can put this back together when they get it back home. Because I think if they had a soldering iron they wouldn't have cut this wire. So I'm guessing they don't have... I just have to tack this on now. It's nothing serious here. It's kind of a temporary connection. And it's just the voice coil leads. It's not the... there's no... it's a permanent magnet speaker. There's no induction coil in there. No high voltage from the power supply or anything like that. Yeah, when I was a kid playing around with this stuff, I didn't realize that. And a lot of speakers carried the B+ right up into their coil. It's amazing I never got shocked. Never got shocked that way. Anyway, I got shocked lots of ways. Okay, so we have the wires secured. A little bit of bare wire here sticking out, but I'm not going to worry too much about it. No antenna on this radio, so we got to do something about that. Hey, you've all heard me complain about noise and bad antennas and stuff like that if you've been watching a lot of my videos. So I did something about it, and that's this whole arrangement down here. The camera's not focusing too well, is it? But anyway, all these, which you'll recognize as TV cable connectors and splitters, these now, this one here carries the antenna, my outdoor antenna signal, shielded all the way in to here. And this one's carrying RF signals coming out of signal generators up here. And I'm going to be making test leads out of these TV cables because I have a lot of them. And this is a very practical approach for me. I have a lot of this kind of stuff laying around. Probably most people who are hanging on to wires and bits and pieces probably have a lot of this stuff too. So I'm going to use that as my connection center. So the result is I have a good antenna connection coming into my shop now. And here it is. Let's put it on. Also, somewhere along the line, because I made a lot of changes to computers and routers and all kinds of stuff, somewhere along the line I eliminated a big chunk of noise. So I don't know what it is that did it. Antenna ground. But somewhere along the line I did the right thing. This will actually be the first time I've really used this, you know, in a working situation. So maybe I talk too much. You should really give this thing a go. I may find out that, contrary to what I think, maybe I still got problems. Let's see. That means I got quite a few radios now connected to my outdoor antenna. 1, 2, 3, 4, plus this one. 5 radios, all just kind of paralleled onto the antenna. 4 of them are in my office, my own personal radios that I use. Okay, so we have the speaker connected, we have the antenna connected, we have the volume turned down, the switch off. Quick safety check. Hey, here's the magic eye. Haven't seen any magic from the magic eye yet. And of course the B plus was suppressed when the one capacitor that was in here had a bad, it was almost completely shorted. I was pulling down the B plus quite a way, so maybe that's why. Okay, we're going to put it on current limiting. I didn't do this very well. Okay, we'll be on the 40 watt bulb, so it's a high limitation to start with. Voltage today, 124. I should really complain. My voltage is too high. And we are ready to go. Here we go. Okay, a little bit of light on the bulb. Voltage running around 80%. Nothing bad happening though. Oh. A little bit of a hum coming out of the speaker now. Bit of noise from the volume control. We don't know what band we're switched on here, so let's gonna have to play the guessing game here. It's all the way this way. That. Okay, there's a distinctly different hum in this position from the other two. So I'm going to guess the other two are the radio positions. That's phono, probably AM, probably shortwave. So we'll come back to the AM. That's full volume. Or is it? We're getting nothing out of it. This radio also had a weak tube right here, and I replaced it with another one. But the output tube checked good. You know what else? I don't know if you can see this on camera. Right here. No, it's hidden from view, but you can probably see this one. This is one of these slug adjustments for a coil. And there's 1, 2, 3, 4 sticking up, but one of them is screwed down almost to the point where it's disappeared through the holder, which is sometimes a sign of a problem in the radio, and it had to be tuned to an extreme to make it work. Just an observation. Well, let's see if we can test the audio side of this. Maybe I should give it. Let's give it more voltage here. More voltage. There we go. Oh. Well, that might have been the light bulb. I'm commenting on, I just managed to see the supply voltage meter dip during one of those crackles, and I think it was just the light bulb I was screwing in. I don't think it was a radio. So okay, now we got full. We got full here. Full nothing. Full nothing. And we got a light going on and off. And let's just try this other band, just in case I'm wrong. Can easily be wrong. Yeah, there's no radioactivity here at all. Radioactivity. It's a little play on the alarm that went off earlier. Okay. Let's Let's flip the radio over and poke around in the back. We'll just switch it off to do this. This radio is nice, you can flip it right upside down. Power on again. Take a look at some voltages. First one is the B+ voltage. Let me get this voltmeter where you guys can see it. Dude, put it right there. Okay, so here's that resistor I put in. On one side, I'm looking at almost 300 volts. The other side, 280. So well, that's pretty high. Okay, on the coils, 280 on that one. 280 on that one. Coils seem okay, both sides of the coil. Okay, 280 there, 280 there, 280 there. Okay, so it looks like the coils are good, the IF coils. Heard a little noise there when I was brushing one of them. So we're moving further up into the radio here, because there's nothing from the antenna. Nothing coming from the antenna. See if we can get the audio section to come to life here. And that should be doing it. If we're switched on phono, okay, I think that's phono. There we are. Oh, there we go. Got some action finally. So that proves a couple things. One is this is the volume control, not this. This must be, I think that's tone. And we also know now that that is definitely phono. Okay, we're on radio. Can't tune it because it's sitting on the tuning wheel here. Nothing at all coming out of the radio portion of things. So it looks like we'll have to do a little bit of circuit tracing and testing. We could look at the voltages on some of these IF tubes. There's probably one tube here is the RF tube. The detector, all that stuff. Could be the oscillator's not oscillating. That's quite possible. I haven't been able to find any information out about this radio, unfortunately. It's a little harder when you don't have the schematic to do this kind of stuff. Hey, let's give it full voltage. Now we know for sure the volume is turned up. We know for sure it's set on a radio band. Once again, a little bit of tuning. Nothing. Nothing comes out of it. Okay. Let's check a couple of... Oh, what was that? For a moment there, I thought I heard something. We'll look at some tube voltages here. I'll pick on this tube first. There's pin 1. I'm sure you can't hear this, but when I touch the pin 1, sound comes out of the speaker. No voltage. Pin 2, no voltage. Pin 3, no voltage. Pin 4, I got this set right. I surely do. There's that sound coming and going again. Oh! Okay. We better turn it down a bit. Looks like that doesn't make much difference, does it? Oh, it does. 300 on whatever that is. Noisy pin. Hey, what's happened? A hum has developed in the radio just now. Just while I'm doing this. Isn't that interesting? I wonder if the radio's come back to life. Could do this all day, right? Okay, let's skip to just the cross capacitors here. To ground. 7 volts positive. That's kind of weird. Okay, so we got 98 on one side, 7 on the other. That's strange. 0, 0, 3 volts. That 98 on one side. I don't like it. 3 on the other. I don't like that. I think we're changing all these gaps. I think that's just about 73 on one side, 0 on the other. 73 is kind of weird. Of course, I got it on current limiting again, so maybe I've knocked the B plus way down. It's still up over 200. Here's one that's zero volts on the high side of the capacitor. See, that capacitor, it you know, it may be not shorted, but it may have no capacity left in it. Oop. Okay, I think it's pretty clear. We gotta change all the capacitors in here, I think. I think that'll be our next step.